Welcome to Impact Physics. My name is Mr. Oporom Darlington Chetachi. So today we are going to be looking at question 11D. Question 11D, by 2022. Question 11D, by 20. Let me indicate it. 11D, 11D. So I'll just read the question for you so that we'll start solving immediately. So question 11D reads: a 40-volt electric heater is used to supply a current of 12 amperes for 1400 seconds to a body of mass 1.5 kg. At its melting point, the body melts and its temperature rises by 60 degrees Celsius in an extra 1.2 minutes. Calculate the I, latent heat of fusion of the body, II, specific heat capacity of the body. Is that okay? So we are going to be looking at that briefly. The first one is latent heat of fusion. That means it's melting. Then the second one is specific heat capacity. Okay, so I've already written out all the parameters. This is the voltage, you have the current, you have the time, and then you have the mass. So latent heat will give you mass times specific latent heat of fusion. I'll put L sub F. This one is specific heat latent heat, specific latent heat of fusion. This one is latent heat of fusion, I mean to say. Sorry for that. So what I'm asked to find is this. But remember, this heat was supplied by an electrical device. So the work done by an electrical device is given as IVT. IVT. This is the current, potential difference of voltage, and this is the time. So I will replace this heat with this IVT equal to what? M L sub what? F. So now I'm not looking for this IVT. So my H will just be equal to IVT. And this will be equal to what? What's my I? My I there is 12 times my V equal to what? 40 times my T equal to 1000 what? 400. Am I correct? So we are going to have, if you multiply these three, you're going to have 672,000 joules. So this will be the latent heat. So the next question is to find this um, specific heat capacity, right? So let's do that. So if we want to find that, it means that the ice melted and then there was a temperature increase. So that means you're dealing with water. So we're going to have, or liquid. So we're going to have the heat, which will be, the heat will be equal to what? MC change in temperature. Look at this. So, but remember that this heat was supplied by electrical device in an extra 1.2 minutes. Look at this, 1.2 is a minute. So I kind of converted it. So now this will be IVT equal to MC change in what? Theta. Pay attention. So if we proceed, what's my I? My I is going to be the current. The current is still steady. Potential difference, the voltage 40 times the extra time will be what? 72 seconds equal to, remember that the mass here is what? 1.5. Then what is this? Is what we're looking for, specific heat capacity, then times change in temperature is what? 60. All we need to do is to make C subject of the what? Formula. If we do that, we have 1.5 here times 60. We do the same thing here, we have 1.5 here times what? 60. So if you do this with your calculator, you're going to be having 384 joules per kg. I would love to say per Kelvin, but since we already have Celsius here, I will say per Celsius. So maybe you're going to argue about this. Please do well to argue. And I will also tell you why I did that. I stand to be corrected. Thank you very much. My name is Mr. Darlington Oporom. I'm here to simplify your physics and mathematics journey. Do well to subscribe to my YouTube channel and follow me on other social media platforms.